All right, guys, let's see if we can get up to 100 today. So number 81, so this one's a proof. So you need to show that the left side equals the right side. Remember, always start on the hardest side first, which is clearly the left side. So here they're asking me to add two fractions. If you're adding two fractions, you need a common denominator. When the two denominators are completely different, to get that common denominator, just multiply them together. Okay, and then let's play the what's missing game. So let's look at this. I've got a cosine here. I have a cosine here, but I needed to have a 1 plus sine x as well. So I'm going to multiply this by 1 plus sine x, which means I'm going to multiply this by 1 plus sine x. Okay, now this ends up being a FOILing problem. So here we've got 1 times 1 is 1. Then we have 1 sine x plus 1 sine x, which is 2 sine x. And then we have sine x times sine x, which is sine squared x. Let's look at the next one. I have a 1 plus sine x here. I have a 1 plus sine x here, but I need another cosine of x. So let's multiply this by cosine of x, and then cosine times cosine is just cosine squared x. Okay, so I added those two fractions together, and now what I see here is that I've got this sine squared plus cosine squared. Guys, remember, that's like the mother of all identities, right? Sine squared plus cosine squared equals 1, and then I can add these ones together. 1 plus 1 is 2, so I get 2 plus 2 sine x all over cosine of x times 1 plus sine of x. And then let's kind of take a peek. I want it to equal 2 sine x, which it does not, okay? But let's see if we can fix this up. What I see on the top here is that they both have 2's. So let's factor out the 2 using a GCF, and you're going to be left with 1 plus sine x all over cosine of x times 1 plus sine x. And now these guys are going to cancel out, leaving me with 2 over cosine of x. Now, let's look again. I want it to equal 2 secant x. So I've got the 2. And you guys, I could put a little times 1 here. 1 over cosine actually equals secant. So this is just 2 secant of x. So I got what I wanted. Okay, now number 82, there's really two ways you can do this problem on this one. You can start on the left or on the right. I would assume that most of you would probably start on the left-hand side. So let's go ahead and do that. So secant. Secant is 1 over cosine. And then tangent is sine over cosine. So that's not actually that bad. And they're asking me to add this together. So I need a common denominator. And look at that. I've already got one. So that's kind of nice. So my common denominator is cosine of x. And then the top, because both bottoms are cosine, is just going to be the same. It's going to be 1 plus sine of x. But then look, I want it to equal this. It's kind of there, but not quite, right? So what I need is I need a 1 minus sine x on the bottom. I don't have that here. So what I'm going to do is I'm going to multiply by what I need. So I need a 1 minus sine x on the bottom, so I'm going to multiply by it. But if I multiply something by the bottom, I have to multiply it by the top as well. Okay, so let's see what I end up getting here. Okay, the top part, these are conjugates. So 1 times 1 is 1. Sine times negative sine is negative sine squared. And then on the bottom, I still have this cosine of x, 1 minus sine of x. And then we know by our identities that 1 minus sine squared just equals cosine squared. So I have cosine squared x over cosine of x times 1 minus sine of x. But then you guys look, I've got one cosine here and one cosine here. So getting rid of one cosine there is just going to leave me with cosine of x all over 1 minus sine x, which is exactly what I wanted. Okay? All right, now solving these trig equations. All right, so you want it to be equal to 0. If you can factor. If you can't, try to get the x all by itself. So on this one, I can definitely factor. This is a GCF. So what's the GCF? It's a tangent. So if I pull out a tangent of x, I'm going to be left with tangent of x plus 1. You guys, again, double check that. Some of you still kind of struggle with this. Look, tangent times tangent gives you tangent squared. Tangent times 1 gives you the tangent. Okay, now setting each of these factors equal to 0. Here we're going to have tangent of x equals 0. Here we're going to have tangent of x plus 1 equals 0. So let's solve the one on the left first. So on this one, where does tangent of x equal 0? Well, it's definitely not on my chart. So I'm thinking it's going to be somewhere right here on the x and y axis. So remember, here we have 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. This is cosine, sine, cosine, sine, cosine, sine, cosine, sine. So it's asking, where does tangent equal 0? Well, the problem is there's no tangent. But I do know that tangent is sine divided by cosine. So it's basically saying if I divide the sine and the cosine, which one is going to give me a 0? Well, you guys, one thing you need to remember, 0 over 1 is 0. 1 over 0 is undefined, right? So where do I get 0 over 1? Here, 0 divided by 1, and here, 0 divided by negative 1. So in both of these spots, you're going to get a 0 on the top. So either 0 over 1 or 0 over negative 1, both of those equal 0. And where is that happening at? So right here, I can highlight it again. It's going to be happening here, and it's going to be happening here, okay? So that's going to be at x equals 0 and at x equals pi. So there's my two answers for that. Now this one, if I move the 1 to the right-hand side, I'm going to get tangent of x equals negative 1. That is actually on my chart. So let's draw this out. Where is tangent negative? So according to all students take calculus, tangent is going to be negative in quadrant 2. And it's going to be negative in quadrant 4. The reason why I'm picking those is because it says that the tangent is a negative 1. Now, tangent equals 1 at pi over 4. So let's count by pi over 4s. 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And my answer is going to be the highlighted one, so 3 pi over 4 and 7 pi over 4. So actually, this problem has 4 answers, the 0 and the pi, and then the 3 pi over 4 and the 7 pi over 4. Okay? All right, number 84. Okay, this one I can't factor on the left, sadly. So let's just try to get the x all by itself. So let's add 3 to both sides. So I get 4 cosine squared x equals 3. Then let's divide by 4. So I get cosine squared x equals 3 over 4. And then let's take the square root of both sides. I'm going to go ahead and square root top and bottom. So it's going to be giving me cosine of x equals plus or minus the square root of 3 all over the square root of 4 just equals 2. Okay, so let's analyze this. I want to know where cosine is positive or negative. Well, cosine is positive in quadrant 1 and in quadrant 4. Cosine is negative in quadrant 2 and quadrant 3. So remember, every time you have that plus or minus, you're going to have answers in all 4 quadrants. And where does cosine equal radical 3 over 2? Well, that's at pi over 6, right? So this is going to be pi over 6. 5 pi over 6, 7 pi over 6, and at 11 pi over 6. And all 4 of these guys are going to be your answers. Okay? All right, let's look at 85. So this one, again, I can't factor that on the left, so let's try to get that x all by itself. So let's add radical 2 to both sides. So you get 2 sine 2x equals the square root of 2. Then let's divide both sides by 2. So I'm going to get sine of 2x equals radical 2 over 2. Now look, this is a double angle, which means that I'm going to go around the unit circle 2 times. So first, it says, where is sine positive? So sine is positive in quadrant 1 and in quadrant 2. So that's where all my answers are going to lie. But where does sine equal radical 2 over 2? That happens at pi over 4. So I have pi over 4. 3 pi over 4. I'm going to keep counting because of this double angle. I have to go around the unit circle twice. So this is 5 pi over 4, 7 pi over 4. Let's go around one more time. I'll have 9 pi over 4 and 11 pi over 4. I'm going to go ahead and stop because my answers are only going to be in quadrant 1 and 2, so no need to keep going. Now look, these are not your answers yet. These answers are what 2x equals. So I have 2x equals pi over 4, 3 pi over 4, 9 pi over 4, and 11 pi over 4. But I don't want to know what 2x equals. I want to know what x equals. So let's multiply both sides by 1/2. So you're going to get x equals, if I multiply all of these by 1/2, the bottoms are just going to turn into 8. So this will be pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8. So those should be your 4 answers. Okay? All right, number 86, a little bit tricky. I can't factor, right? So I'm kind of stuck. But I do have a cosine squared, which I can turn into a 1 minus sine squared. The reason why I do that is so that I can have all sines in there, so I don't have two different trig functions. So let's go ahead and do that. And then look, if I subtract 1 from both sides, cancel, cancel. Now I have negative sine squared x plus sine x equals a big fat 0. Now look at the left side. I can factor now. I can do GCF. I can take a sine of x out of both of these. So if I take a sine of x out of here, I'm left with a negative sine of x. If I take a sine of x out of here, I'm left with a 1, and then that equals 0. So let's see what I've got. On the first one, I want to know where sine of x equals 0. Well, let's look. Again, we've got this 1, 0, 0, 1, negative 1, 0, 0, negative 1. Remember, it's cosine sine, right? So the y value is actually your sine. So where does the y value equal 0? Here and here. So there we've got x equals 0 and pi. So there's two of my answers. And then I've got negative sine of x plus 1 equals 0. If I subtract 1, I'm going to get negative sine of x equals negative 1. If I divide by a negative, I'm going to get sine of x equals 1. So where does the y value equal 1? And that would be right here. Okay, down here it equals negative 1, so I don't want that one. So it's just going to be at x equals pi over 2. So my three answers are then 0, pi, and pi over 2. All right, let's look at 87. So 87, let's make this equal to 0 first by adding the 1 over. So I'm going to get 2 sine squared x minus 3 sine x plus 1 equals 0. And then can I factor this? Well, let's try. Because I have 3 terms and a number in front, this is going to be the big star factoring. So I need 2 numbers that multiply to give me 2 and add to give me negative 3. That's going to be negative 2 and negative 1. And then I want to divide by the leading coefficient, which is a 2. This is kind of stuck the way it is. This reduces to negative 1. So when I factor this problem, I'm going to get sine of x minus 1 times sine of x minus 1/2 equals 0. Now, setting both of these guys equal to 0, on this one, I want to see where sine of x equals 1. On this one, I want to see where sine of x equals 1/2. And I just added the 1 to the other side, added the 1/2 to the other side. Okay, so where does sine of x equals 1? Remember, you guys, cheat if you can, right? Look, I already found that right here. Sine of x equals 1 at x equals pi over 2. So I already have that answer down. So there's 1. And then where does sine of x equal 1/2? Well, because this is a positive 1/2, that's going to happen in quadrant 1 and quadrant 2. That's where sine is positive. And sine equals 1/2 at pi over 6. So this is going to be pi over 6 and 5 pi over 6. So you're going to get x equals pi over 6 and 5 pi over 6. So again, 3 answers here, pi over 2, pi over 6, and 5 pi over 6. Okay? All right, number 88. Okay, can't factor the left, so let's go ahead and try to get the x all by itself. So if we divide both sides by 3, we get cosecant squared x is 4 over 3. Let's go ahead and try to get rid of the squared by taking the square root. So you're going to get cosecant of x equals plus or minus. The square root of 4 is 2. The square root of 3 is square root of 3. Now look, don't rush to rationalize this. Let's look at what we have here. Cosecant is the flip of sine. So if I just flip both sides, I'm going to get sine of x equals, I'm going to flip this plus or minus radical 3 over 2. So it kind of rationalized itself, which is kind of nice. Now again, I've got this plus or minus issue. Remember, if I have a positive or a negative, it's going to end up in all 4 quadrants, okay? So where does sine of x equal radical 3 over 2? That happens at pi over 3. So this is going to be pi over 3, 2 pi over 3, 4 pi over 3, and at 5 pi over 3. So all of those are going to be my answers. Remember, you guys, these answers are coming from your chart, so make sure you have that memorized. All right, 89. So on this one, you guys, you will get the identities for this, so please don't panic. So I want to find the cosine of 2x. If you look at your identities, cosine of 2x actually has 3 different identities. So one of them is that it equals cosine squared x minus sine squared x. The other one is 1 minus 2 sine squared x, and the third one is 2 cosine squared x minus 1. Now, even though cosine of 2x has 3 different options, it's kind of nice that you have options because you can pick the easiest one. So look at the information they gave you. They told me what sine of x equals, so how about we pick the one that just has a sine in it so I don't have to find the cosine, okay? If you pick the other two, you'd have to take this into consideration, draw a triangle, and find stuff, which is kind of annoying. All right, so I'm going to pick the second one. So I have 1 minus 2 sine squared x. I'm going to do this a little bit differently because a lot of you had issues with this on the test. What does sine squared mean? Sine squared means the sine of x times the sine of x, right? Isn't that the same thing as sine squared? So now let's plug it in. So this is 1 minus 2 times, what is the sine of x? The sine of x is 4 over 5. What is the sine of x? The sine of x is 4 over 5, so I'm just plugging it in. Okay, so let's multiply this out. So put this over 1. 2 times 4 is 8. 8 times 4 is 32. And then 1 times 5 is 25. Now, putting this together, you can rewrite a 1 as a 25 over 25. And then 25 minus 32 is just negative 7 over 25. Okay? All right, halfway there, let's look at 90. So it says cosine of x is negative 1/3, x is in the third quadrant, find the sine of 2x. Now again, this will be given to you. The sine of 2x equals 2 sine x cosine of x. That's the only identity, so I do not have another choice. Okay, so let's see what we have. This would be 2 times, I don't know what sine of x is, but I do know that cosine of x is negative 1/3. So my only job here is to try to find out what sine of x is, and the only way to do that is to draw a triangle in quadrant 3. So let's go ahead and do that. Here's quadrant 3, here's my triangle, this is my angle x, sorry, I was going to call it theta. So this is angle x. So it says cosine of x is negative 1 over 3. So this is adjacent over hypotenuse. So the adjacent side is negative 1. The hypotenuse is 3. If you use Pythagorean theorem, you guys, this is going to end up being, you can go like negative 1 squared plus b squared equals 3 squared, right? So that's 1 plus b squared equals 9. If you subtract 1, you're going to get that b squared equals 8. So b equals the square root of 8. So this is going to be radical 8. But because we're going down, it's also going to be negative, okay? So the question was, what is the sine of x? Well, sine is opposite over hypotenuse. So this would be negative radical 8 over 3. Now, multiplying all these guys across, a negative times a negative is a positive, so that would just be positive 2 rad 8 all over 1 times 3, which is just 9. Now, if you wanted to, you guys remember 8 is just 2 rad 2, right, all over 9. And then you can just go 2 times 2 is 4, so that's 4 rad 2 over 9. Okay, if you're wondering how did I get radical 8 is 2 rad 2, let me go over that one more time. Remember, this is 2, actually, let's do it this way. 8 is 4 times 2. The square root of 4 is 2, and then you have that rad 2 left over. So that's how I got that, okay? All right, so this one you may need a calculator for. Okay, so you have a store with 15 sofas, 12 lamps, and 10 tables at half price. How many different combinations of a sofa, a lamp, and a table can be bought at the sale? So a sofa means one sofa, a lamp means one lamp, and a table means one table. So look, I have 15 sofas, and I'm trying to choose just one. So I'm choosing one, okay? And then I have 12 lamps, and I'm just choosing one. And then I have 10 tables, and I'm choosing one. And when you have 3 different events like that, you always want to multiply them together to get all the different possible combinations. Now, if you plug this into your calculator, the 15 choose 1, you should get 15. This right here is just 12, and this right here is just 10. And plugging that in, I believe it was like 1800 or something. I know I did this in class with you guys, but I don't remember. Let's try. Yep, 1800. Okay, so this is going to be 1800. All right, let's look at 92. A car dealer offers a choice of 6 vinyl top colors, 18 body colors, and 7 upholstery colors. How many color combinations R there. Okay, so look, you're just going to choose, when you're buying a car, right, you're only going to choose one vinyl top color, one body color, and one upholstery color. You're not going to have a color, like a car that has like, I don't know, 2 different upholsteries inside, right? That would be kind of silly. So you basically, you have 6 vinyl top colors, but you're choosing only one. And then you have 18 body colors and you're only choosing one. And then you have 7 upholstery colors, but you're only choosing one. So you guys, exactly the same as the problem above. 6 choose 1. If you plug that into your calculator is 6. 18 choose 1 is 18. And 7 choose 1 is 7. So 6 times 18 times 7, that just equals 756. Okay, almost done. All right, these formulas will not be given to you on the final, so if you need to write them on the note card, please do so. So look, this is your n, this is your r. Let's go ahead and plug it in. So this is going to be 8 factorial, that's your n, all over n minus r, so 8 minus 3, that's 5 factorial, and then the r is just this 3, so times 3 factorial. Now, let's simplify this. I always want to start with the biggest one. So the biggest one is the 8, and I'm going to break it down. So this is 8 times 7 times 6 times 5 factorial. The reason why I'm stopping there is because there's a 5 factorial on the bottom that's going to cancel out with it. So cancel, cancel. And then I have 8 times 7 times 6 all over 3 factorial is actually 3 times 2 times 1, which is just 6. These cancel, and the 8 times 7 is a 56. Okay, maybe pause the video and see if you can do 94 by yourself, right? These are not the hardest questions. I'm hoping that you guys can get these easily. So here's your n, here's your r. Plugging it into this formula, we're going to get 25 factorial over, and then n minus r, so 25 minus 5, that's 20 factorial, times r factorial, which is 5 factorial. Now, breaking this down, again, start with the biggest factorial, which is the 25. So this would be 25 times 24 times 23 times 22 times 21 times 20. And I'm stopping there because of this 20 factorial that's going to cancel out with it. Okay, so you guys, these two cancel. Now, what is 5 factorial? 5 factorial is just 5 times 4 times 3 times 2 times 1, right? So this is 20 times 6, which is 120. So you guys, this thing's getting like really, really big, okay? It's not going to be this big on your final, but I'm actually going to let you put this into your calculator. So let's put all of this into our calculators and see what we get. So it's 25 times 24 times 23 times 22 times 21. And that ended up being, it's just way too big, 6375600. And if I divide that by 120, that ends up being 53130. You guys, even though this is on the no calculator portion of your final, the numbers will be similar to 93, not to 94. That's a little too crazy. Okay, and now here, they did not give you the formula for the permutation. So permutation, P and R, the formula for that is n factorial over n minus r factorial. This is still your n, this is still your r. So let's go ahead and plug that in. So this is going to be 6 factorial all over n minus r, which is 6 minus 3, that's 3 factorial. Break down the biggest one, which is the 6. So this is 6 times 5 times 4 times 3 factorial. Again, I'm stopping at the 3 factorial so I can cancel these out. 6 times 5 is 30, 30 times 4 is 120. So look, something like this you should be able to handle without a calculator. Okay, let's see how bad this one gets though. This one does not look so good. Okay, same formula. So this is your n and your r. So you have 15 factorial all over 15 minus 7, which is 8 factorial, times r factorial. No, there's no r factorial. It's just 15 factorial over 8 factorial. I forgot it's a permutation. Let's put that right smack in the middle, okay? Now, 15 factorial, that's 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial all over 8 factorial. Ew, okay, let's see what that's left. I have no idea. This is going to be a big number. So I have 15 times 14 times 13 times 12 times 11 times 10 times 9. Let's make sure I did that right. 15, 14, 13, 12, 11, 10, 9. Okay, oh my gosh. Yeah, you cannot do this without a calculator. 3, 2, 4, 3, 2, 4, 0, 0. That's what I got. Hopefully you got the same thing. All right, you guys, almost there. Okay, an urn has 12 black and 8 green marbles. How many ways can 3 black and 2 green marbles be chosen? So you guys, this is a combination because it doesn't matter what order you pick them in. Okay, so I have 12 black marbles and I'm choosing 3. So 12, choose 3. And then I have 8 green marbles and I'm choosing 2. Okay, remember when you have separate events, you want to multiply them together. And at this point, just go ahead and plug it into your calculator. So 12, choose 3. So on my calculator, I'm going to hit 12 and then math, scroll all the way over to PRB for probability and then down to NCR. So it's 12, choose 3. And you guys, for that, I got 220. And then if you do 8, choose 2, so 8, and then again, math, PRB, and then NCR, so that's going to be 8, choose 2, got 28. So 28 times 220, for that I got 6,160, okay? All right, 98. From a group of 6 men and 4 women, how many committees of 2 men and 3 women can be formed? Again, this is still combinations because order does not matter. So look, I have 6 men and I'm choosing 2. So it's 6, choose 2. And then I have 4 women and I'm choosing 3. So 4, choose 3. Again, if you have separate events like that, multiply them together. So putting that into your calculator, so 6. Wow, I started graphing something. That's interesting. Okay, so 6 and then math, probability, and then NCR, 6, choose 2. That ends up being 15. And then 4, choose 3. So 4, math, probability, NCR, and 4, choose 3. I got 4. So you guys, 15 times 4, I can do that on my head, it's 60. Okay? Now, 99, we did not get to probability this year. I'm so sorry. You can cross off 99. That's not going to be on your final. And then let's go ahead and get to 100 so we can finish that off. Okay, evaluate 11 factorial over 7 factorial over 4 factorial. You guys, you should be able to do both of these, guys. So look, 11 factorial is 11 times 10 times 9 times 8 times 7 factorial. I'm stopping there because of this factorial, so I get to 7 factorial, and then I've got the 4 factorial on the bottom. So these guys cancel out. Now, what is 4 factorial? If we write that out, so 11 times 10 times 9 times 8 is what's left over. On the bottom, we have 4 times 3 times 2 times 1. So look at how I'm going to cancel these. 4 goes into 8 2 times. These 2's can cancel. 3 goes into 9 3 times. So on this one, 11 times 10, that's 110. 110 times 3 is 330. Okay? I'll go ahead and do 101 just to get rid of it. Okay, same idea. Maybe pause the video and see if you can do this one. So 10 factorial, start with the biggest one, is 10 times 9 times 8 times 7 factorial. And then we have over 7 factorial, 3 factorial. So these guys cancel out. So I'm left with 10 times 9 times 8. And 3 factorial is 3 times 2 times 1. So again, canceling these, 3 goes into 9 3 times. 2 goes into 8 4 times. 10 times 3 is 30. 30 times 4 is 120. All right. And then you guys, just so we can get rid of more problems, 102 and 103. We do not know how to do those. Don't worry about those. All right. Okay, so it got you up to 100. I hope that helps. Hopefully tomorrow we can finish everything else. All right. Have a good night.